Battle management systems in the 21st century will continue to rely on the most complex and advanced concepts of integrated technologies. Data can be processed, displayed, and communicated at nearly the speed of light and acted on anywhere in the world and its orbits. Just as important as gathering, processing, and disseminating information is masking it and being able to move about undetected. Northrop founder Jack Northrop built and tested the first flying wing in the late 1940s. His results came in the form of the 8-engine YB-49 and 4-engine YRB-49A. Tests proved it flight-worthy despite its lack of traditional wing surfaces. Few details are publicly known about the stealth anti-detection technology of the B-2. Obvious radar detection masking is inherent, though, in design elements like the sawtooth trailing edge aft of the engine for a minimal infrared signature. Scalloping also helps reduce the B-2's radar profile. After years of anticipation, design team members and others gathered for the B-2's maiden flight. Each packing 19,000 pounds of thrust, the four F-11 8GE 100 non-afterburning engines were fired up. The time had come to fly. Maximum takeoff weight is 350,000 pounds with 50,000 pounds of conventional or nuclear ordnance. An example payload could be 16 short-range nuclear attack missiles mounted on 2 side-by-side rotary launchers or B-83 nuclear gravity bombs. Configured with conventional bomb racks, the B-2 will hold up to 80 500-pound munitions as well as other weapons, including sea mines. Resident Air Force and Northrop test pilots operate the B-2 from a bank of CRTs in a 2-man cockpit. Cockpit design allows for the addition of a third flight deck officer for expected technological upgrading in the projected 30-year duration of this program. Stealth technology enables an unprecedented payload launch closer to target than even our most ready ICBMs while maintaining protection of the launch platform. Flight and mission data is processed and transmitted at space-age speeds between the main supercomputers and the processors on board. Human contact with the in-mission B-2 allows alternate attack strategies to be implemented in mid-mission with more effectiveness and flexibility. The B-2 stealth bomber has now begun the lengthy test flight phase, taking anti-radar detection and modern bomber technology into the 21st century.
This plane is the latest of the X series of aircraft called the X-29. At first glance, the plane seems ordinary until your perspective changes. The 30-degree forward-swept wings, set far back on the plane's fuselage, make it appear to be flying in the wrong direction. Through the use of the X-29 as a test vehicle, engineers will be able to explore the forward-swept wing's unique mixture of speed, agility, and slow flying qualities. They will also explore the interaction of the wings with the forward canards and rear strake flaps. In this design, all control surfaces are linked together by computer. The ultimate goal for those involved in the program is to prove the benefits of the forward-swept wing, to confirm the X-29's airworthiness, and when these goals are accomplished, to make sure the results are transferred to government and industry. What we learn in this program will help build the next generation of fighter and commercial aircraft.
This airplane, the XV-15 tiltrotor, represents one of the most versatile research aircraft coming out of aeronautical development today. The plane's unique feature is that it can set its rotors at any position from full upright helicopter mode to nearly 90 degrees forward, much like that of a conventional turboprop. The quiet performance of the tiltrotor combines the ability to take off and land like a helicopter with the speed, payload capacity, and range of a fixed-wing airplane. Initially conceived in the late 1970s, the tiltrotor represents a combined effort by NASA Ames Research Center, the U.S. Army, and Bell Helicopter Textron. The Defense Department is planning to purchase a larger version of this plane called the JVX. The XV-15, NASA technology working for greater speed, efficiency, safety, and versatility in aeronautics.
U.S. fighters over a 21st century battlefield would have their most valuable compatriot ever in the AH-64 attack helicopter. With its own radar jamming and land laser rangefinder, the Apache pilot can get a fighter pilot on target from a safe distance in order to launch a strike. The Apache crew, equipped with heads-up target display built into their helmets, locks on and tracks targets without looking away from the chopper's flight path. They can light up targets with a laser beam which feeds the fighter pilot a reflection on his gun sight. The Apache has a vertical climb rate of 2,460 feet per minute with 154 knots true airspeed. With a maneuverability envelope between 3.5 Gs to minus 0.5 Gs, the Apache can make quick turns and changes close to the ground or while engaging other aircraft. Designed to survive direct hits from armor-piercing incendiary rounds, the Apache should be able to complete its mission and return to base. Most of the armor is designed around the protection of the crew and its fuel. The Apache's principal mission is destruction of enemy armor with 16 heavyweight Hellfire anti-tank missiles. It can also be equipped with various other weapon configurations lethal against a wide variety of targets. The AH-64 is the only platform in the world capable of navigating to a target at night in the types of weather presented in the European theaters. The pilot rides in an elevated rear seat just aft of the co-pilot gunner's compartment in the nose. Both crewmen can launch the full complement of Apache's anti-tank fire. While the Apache is a valued sighting and fighting team member over the battlefield, advanced radar technology at sea is making battle groups less vulnerable to all-out attack. Tracking up to 200 targets simultaneously, Aegis cruisers are the most sophisticated fire control operation centers ever put in action. In a multi-vehicle attack from all directions, each target can be assigned to the weapon system required. A single Aegis carrier running point can provide enough fire control for an entire battle group.
The best known of the Fleet Air Defense weapons is Standard Missile, which evolved from Terrier and Tartar missiles and has continued to adapt to the ever-increasing threat to the free world's navies. Standard missile is manufactured in two distinct surface-to-air configurations. The medium range uses a dual-thrust rocket motor, and the extended range has a separable booster. There are two versions of Standard missile. Standard Missile 1 has been in production since 1968, and Standard Missile 2 since 1976. Both these missiles have been continually upgraded by incorporating evolutionary technology to increase accuracy, reliability, and firepower to meet the changing threats. Today, Standard Missile 1 uses the same modern monopulse receiver as the newest version, Standard Missile 2. Standard Missile 2 uses this monopulse receiver in conjunction with inertial reference and command links. Such features have significantly reduced reaction time while increasing firepower and area coverage. The latest version of Standard Missile 2 has been improved by adding new propulsion units to both the medium range and the extended range configurations. The new Mark 70 booster for the extended range uses the same metal parts as the proven SM-1 Mark 12 booster, but has a new propellant grade. The new Mark 104 dual thrust rocket motor incorporates the latest in propulsion technology and increases missile velocity considerably.
AWC, Captain. My take is that there are currently 5 targets.
A digital signal processor permits engagement of tomorrow's higher speed and reduced radar cross-section targets. The threat continues to improve.
You've got 5 airborne right now, and the 5th.
The combination of Standard Missile, its planned evolution, and the Aegis combat system will provide the United States with defense against both high-altitude and low-altitude anti-ship threats through the 1990s. Standard Missile is deployed not only on U.S. ships, but also on ships of 7 allied countries. The AIM-7M all-weather missile system was developed for the Navy and Air Force air superiority fighters to defend against enemy aircraft. General Dynamics is second source manufacturer of Sparrow. The monopulse receiver of the AIM-7M offers improved performance against maneuvering targets in the presence of countermeasures. The surface-to-air version, RIM-7M, also known as Sea Sparrow, is used in a self-defense role with the U.S. Navy and its allies. RAM, the rolling airframe missile, is the basis for a new generation quick-reaction self-defense system designed to effectively counter the anti-missile threat. By applying the rolling airframe principle, guidance, signal processing, and control channel requirements are substantially reduced. This results in fewer components, lighter weight, smaller size, increased reliability, and lower cost of this 5-inch diameter missile. The use of passive radio frequency and infrared guidance provides for autonomous in-flight operation, allowing simultaneous target engagements and the high rate of fire necessary to assure ship survivability during saturation attacks. When the missile is launched in the direction of the target, it maintains that direction until the passive RF guidance signals call for a course correction. RF guidance signals also point the IR seeker toward the target until there is sufficient IR signal to acquire the target in terminal homing.
Phalanx, the Navy's close-in self-defense weapon, a totally autonomous standalone system. Phalanx is a weapon system designed to handle close-in threats, the need for which has been dramatically illustrated by the increased use of anti-ship missiles against naval targets. Its automatic search, detect, track, and fire features makes it an autonomous weapon system, with no dependency upon other ship systems. Phalanx is an important layer of the layered defense concept. Along with a high fire rate 20mm Gatling gun, Phalanx lethality is enhanced by a unique gunfire control technology called closed-loop spotting. By tracking both the target and the projectile in the vicinity of the target, an error measurement is obtained. This error is automatically corrected to align the projectile with the target to provide a kill. These projectiles were designed and developed especially for the Phalanx gun and consist of sub-caliber, spin-stabilized, heavy metal penetrator rounds that provide maximum lethality. Phalanx makes use of target analysis data during an engagement to make a kill determination. After verification of a kill, the system will resume search for new targets. In firings against tow targets, drones, both subsonic and supersonic, and bombs, the accuracy of Phalanx was continuously proven. Rapid reaction time from detection to engagement was confirmed by tests in which target drones were launched at Phalanx in rapid succession. As a result, multiple target reaction time was proven effective.
The Tomahawk family of cruise missiles, developed to provide a versatile weapon for America's defense. Tomahawk's features: it is small, low-flying, far-ranging, evasive, reliable, and accurate. The Navy's sea-launched cruise missile, Slickum, was the first member of the Tomahawk family and continues in full-scale production. After launch from the torpedo tube of a submarine, just one of 4 launch platforms, the missile broaches, powered by an expendable rocket motor. Control fins deploy for stability. In seconds, the engine inlet and wings deploy. The spent rocket motor is jettisoned. An efficient turbofan engine takes over, and Tomahawk speeds toward its programmed target. If the assigned target should be an enemy ship, Slickum systematically searches a large area of the sea, locking onto the signature of the target ship, and with precision accuracy, homing in for the kill. Fitted with a conventional or nuclear warhead, Slickum can be assigned a target up to 2,500 kilometers inland. Navigation is inertial, refined with updates from the Terrain Contour Matching System, TERCOM, and has an on-target accuracy within meters. A submunition dispensing variant of Tomahawk is designed to fly against revetted aircraft and similar targets. In this variant, packs of submunitions are ejected from the universal payload bay. The universal payload bay can also be used for other types of submunitions or countermeasures. With submunitions gone, Tomahawk then flies on to attack a final target as an accurate kinetic force projectile. Slickum is readily launched from surface ships. This armored box launcher is on the battleship New Jersey. CGN-9, 36, and 38 class cruisers, plus DD-963 class destroyers like the USS Merrill, are also receiving Tomahawk capability. Another launch configuration is vertical. Here, the missile is stored below decks in an upright position and launched straight up. On CG-47 class cruisers, DD-963 class destroyers, and DDG-51 class guided missile destroyers, each ship is able to carry a larger number of missiles in a limited space, increasing firepower. In submarines, 12 tubes located in the bow of SSN 688 class boats provide the vertical launch capability, in addition to launch from the torpedo tube. Submarines provide Slickum with ideal launch platforms, virtually free from interdiction and adding a new dimension to fast attack boats.
Advances in submarine performance have necessitated corresponding upgrades in anti-submarine warfare torpedoes. Recent strides in Soviet technology present a significant potential threat. This has alerted our government to the need for a heightened defense effort. The Soviet Alpha-class submarine, for example, has been reported by Jane's fighting ships to be the fastest submarine in the world. Consequently, the United States has a great need for an advanced capability torpedo, one that will counter submarine threats with more speed and accuracy than ever before. An improvement over the Mark 48 torpedo, the Mark 48 ADCAP torpedo will run faster, go deeper, and travel farther than any other torpedo used by the United States Navy. This submarine-launched heavyweight torpedo is capable of acoustically homing in on fast-moving targets in a diversity of environments. Its guidance and control subsystem serves as a computerized internal brain, which is able to identify targets. The intricate subsystem directs the torpedo to the target, successfully completing search, homing, and re-attack missions. The digital technology of the ADCAP contributes to the Navy's capability to provide an at-sea deterrent to present and growing future threats.
When the concept of a submarine-launched missile was first proposed in 1955, skeptics said it could never work. But the successful launch of a Polaris test missile from the submarine USS George Washington on 20 July 1960 ushered in the era of the fleet ballistic missile, and the Navy's submarine-based weapon system has stood the test of time. The Navy's first fleet ballistic missile, the Polaris A-1, had a range of 1,200 nautical miles. The Polaris program extended the missile's reach, achieving a range of 2,500 nautical miles with the A-3 missile. Then the Poseidon, or C-3 missile, introduced multiple warheads, each capable of reaching a separate target, significantly enhancing the system's effectiveness. And the Trident development program resulted in a more survivable deterrent, an improved missile with a range of 4,000 nautical miles. And a new submarine, faster, quieter, and most of all, larger, carrying 24 missiles instead of 16. The Trident II, or D-5 missiles, carried on board the Tennessee-class submarines, the newest and most powerful in the Navy's underwater arsenal, incorporate major advances in missile design and manufacturing. For example, graphite epoxy, an extremely strong yet lightweight material, is used for the casings of the solid propellant rocket motors. This, along with other advancements, allows the Trident II missile to achieve a range greater than the 4,000 nautical mile reach of the Trident I.
Just as the ocean's depths present complex defense situations, ground forces are confronted with unique challenges too. Today's military technology and integrated battle management systems provide the basis for state-of-the-art advances on the frontline battlefields of the 21st century.
A new measure of quality in armor has emerged. A weapon system fusing high performance and reliability, advanced technology, and precision craftsmanship. A main battle tank with incomparable crew protection, quickness and agility, firepower. The M1A1. Today's world-class performer. Exceptional design embodied in the M1 series of battle tanks has shattered traditional concepts of armor. The M1A1 has combined high mobility, maximum crew protection, and precise firepower into an advanced weapon system that is second to none. From the manufacturing plant to the field, the M1A1s are tanks which have demonstrated continued high performance in a variety of conditions. tanks which are easily operated, easily maintained, a tank you can depend on. On the battlefield, a weapon system must be depended on to perform whenever called on. The survival of the soldier and completion of his objective are at stake. In service to the United States Army, the M1A1 has continually lived up to its world-class reputation. The M1A1's performance has gained the trust and confidence of the men who operate this remarkable machine. High mobility is a quality very few main battle tanks can claim. The M1A1 main battle tank delivers without compromise. Astounding quickness and acceleration permit use of evasive tactics on the battlefield. The vehicle's high speed, on or off-road, allows it to be positioned rapidly and strategically. A powerful 1,500 horsepower turbine engine provides the vehicle with remarkable speed and quickness. An advanced suspension system enables the M1A1 to maneuver with exceptional agility. The lethality of a fully stabilized 120mm main gun in the M1A1 is coupled with digital fire control and thermal imaging. The system can fire on the move at high speed in all weather conditions, day or night, with tremendous accuracy. Technologically advanced armor, as well as compartmentation of the fuel and ammunition, provide structural safeguards for the four-man M1A1 crew. Onboard systems, like the nuclear biological chemical unit and a fast-acting fire suppression system, have been repeatedly tested to conform to rigid design criteria. The M1 series was designed from the ground up to provide protection to the crew and systems in battle. Low vehicle silhouette and internal smoke generation make the vehicle difficult to detect in combat. These features, combined with unequaled armor protection, quickness and agility, and lethal firepower, all add up to a unique vehicle with unparalleled crew protection. The M1A1, an advanced technology weapon system capable of rugged, continued performance, ready today to meet the challenges of tomorrow. The M1A1, a world-class performer.
Air defense is a key element in any land battle. The Stinger man-portable weapon system provides the foot soldier with a flexible and effective counter to hostile air attack. Weighing less than 35 pounds, this weapon provides the velocity and range to intercept high-speed, incoming, crossing, and outgoing planes and helicopters at greater distances than ever before. This Stinger forward area low-altitude air defense system now gives the U.S. Army, the Air Force, and the Marine Corps a superior air defense shield against helicopters and high-speed jets. Over 300 guided flights have demonstrated Stinger's superior performance against a variety of targets and has verified the accuracy, lethality, and reliability of the Stinger weapon. Annual reliability flight tests and fly-before-buy contractual test results have been outstanding, thus assuring the users of high-quality, highly reliable weapons. POST, an acronym for Passive Optical Seeker Technique, is a highly advanced guidance system which requires only a modular change to the existing Stinger weapon. The combination of rosette scanning and microprocessor control significantly enhances target detection and countermeasures capability. The two-color infrared and ultraviolet rosette scan seeker provides an option to track targets in either band. POST has increased immunity to countermeasures, better background discrimination, and improved signal processing electronics. Stinger POST enhances the high operational effectiveness and terminal lethality of the Stinger weapon system while retaining the advantage of the fire and forget operation. This remarkable weapon system is easily adaptable on a variety of platforms. Stinger can provide an air defense capability for numerous military vehicles, vessels, and aircraft. Ships, helicopters, and land-based vehicles are all adaptable for Stinger weapon mount.
Many directed high-energy weapons are being developed for future use. One such weapon, the Skylight Mid-Infrared Advanced Chemical Laser, or Miracle, couples a beam director with an advanced high-energy chemical laser. In this experiment, a rocket engine mixes various chemicals, exciting their molecules to a higher energy state. When these molecules drop back to a normal state, they transmit photons into an ultra-concentrated beam of light energy. Out in the desert, an experimental Skylight system has been tested successfully, receiving a target designation from a radar beam, then directing its beam straight at the target. The beam tracks the target, thermally burning through at the precise point of aim, slicing through and destroying it. Besides ground-to-air defense, programs like Skylight have the adaptability for other applications, such as anti-missile defense aboard ship. The United States Strategic Defense Initiative is capitalizing on many forms of directed energy. Although most of SDI must be carried out in secrecy, recently released footage is giving us a closer look at these Star Wars projects. In the Delta 181 experiment, payloads of sensors and other test objects are sent aloft, taking position in the Earth's orbit. Delta 181, with a payload of 14 sensors, helped characterize surface test missiles against a variety of space and Earth backgrounds. These ultra-sensitive devices are able to detect differences in groups of in-mission enemy ordnance. Lighter objects are identified as decoys by slight differences in motion. Reporting back to central supercomputers, the data enables the system to act on real warheads and ignore the decoys. Delta 183, the next experiment in the Delta Star series, continues this line of research with a projected 9-month orbital life. After taking position, Delta Star, with an even higher order of sensors, begins collecting data which will characterize the plumes of several sounding test rockets launched at intervals. Studies in kinetic and directed energy have broadened the range of knowledge and generated quantum leaps in advanced military technology. By combining laboratory development and large integrated ground and space experiments, numerous SDI interceptor advances have been made in relatively little time.
Plus 176. Plus 180. Looks like it's spinning and pointing across the field.
In the Bear experiment, neutron particle beam tests exploit the capability of a stream of atomic particles to penetrate deep into targets. During a short space flight, the vehicle carrying the beam accelerator rotates in position while the neutral particle beam is propagated. In this first ever firing of a neutral particle beam in space, no targets were used. Rather, the behavior of the beam during firing was studied to determine the effects of space and lack of an atmosphere. This rotation of the entire satellite fixes aim on the target. Unlike the laser beam, which cuts through its targets, the neutral particle beam penetrates deep inside of ICBMs and other hostile intruders, destroying or disrupting their workings from within.
10, 9, 8, 7.
The hover test experiment showed that it is feasible for vector thrusters to fire for microseconds to keep an interceptor on target. This technology was first achieved on the ground at Edwards Air Force Base. Hover tests at Edwards involved this 21-second flight of an SBI projectile facsimile in a laboratory. The deployment concept for strategic defense would send a number of orbiting interceptors on missions of non-nuclear destruction. Attacking missiles are killed in early phases of flight by the kinetic force of impact at extremely high speed. Ground-based operation of defenses deep inside the atmosphere is being developed by projects such as the Army's Flexible, Lightweight, Agile Guided Experiment, or FLAG. It's a concept of using advanced technology to hit a bullet with a bullet. A U.S. Army Lance missile is fired toward the test area from about 32 miles away. 100 seconds after this target is launched, they raise the 12-foot-long flag in hot pursuit. The improved millimeter wave built-in radar locks onto the Lance. Flag's onboard computer then chooses from 216 rocket motors about the size of shotgun shells, firing the motors appropriate to moving the flag vehicle on the correct course at the corresponding command. This combination of onboard microprocessing and advanced radar gives SDI the guidance necessary for non-nuclear intercept of targets down to Earth and close to home. New technology is replacing old at a faster and faster rate every day. How we live, work, play, and defend ourselves will evolve fantastically in the decades to come. For in the 21st century, not only will we see astounding leaps in advanced military weaponry, but the battlefield itself will be redefined.